Okay, this video is going to go over section 7.3 in your book. It's going to go over how to solve trigonometric equations. Alright, for our first example, it says determine whether pi over 4 is a solution to the equation 2 sine of theta minus 1 is equal to 0. They also ask, is pi over 6 a solution? So, to start off, we plug in pi over 4 into theta for sine, so instead of 2 sine of theta is 2 sine of pi over 4 minus 1. We're going to see if that equals 0. Sine of pi over 4 is square root of 2 over 2. Multiply that by 2 and subtract 1. The 2's cancel out, so you end up with square root of 2 minus 1, which is not 0. So since it's not 0, you can conclude that pi over 4 is not a solution. Now we need to check if pi over 6 is a solution. So you plug in pi over 6 into sine, so it's 2 sine of pi over 6 minus 1 is equal to 0. Alright, pi over 6, I believe is 1/2. Multiply it by 2, and then subtract 1 from it. 2 times, the 2's cancel out, so you end up with just 1. So 1 minus 1 is 0, so pi over 6 is a solution. So for example 2, it says solve the equation cosine of theta is equal to 1/2. And it says to give a general formula for all the solutions and list 8 of the solutions. Now, what this means is, you know how cosine is periodic? So if we take all numbers, all real numbers, that means there are infinitely many solutions. So we need to come up with an equation for those solutions since cosine is periodic. So let's first look at the interval from 0 to 2 pi. Since the period for cosine is 2 pi. Remember, cosine is positive in the first and second quadrant. So the angles here and here would give you a cosine of 1/2. Those angles, I believe, would be at 60 degrees and 120. Or if you want to do it in terms of pi, that would be pi over 3. And also, it actually wouldn't be in this quadrant because cosine's negative. It'd be in this quadrant. So it'd be at 300 or 5 pi over 3. So, what we said, so our two angles are pi over 3 and 5 pi over 3. And that's also periodic, so if we were to add 2 pi to that, to pi over 3, if we were to add 2 pi, that would be a solution. Likewise, if we were to add 4 pi, that means going around the circle twice. If we add 6 pi, that means going around the circle 3 times. So, it's some interval, some multiple of 2 pi. Likewise, if we add some multiple of 2 pi to 5 pi over 3, whatever we get would also be a solution. Remember for here, k is an integer. So, 8 possible solutions would be, and you can go in the negative direction too. Like the number you plug in for k could be negative. So if you plug negative 1 in for k, you'd have pi over 3 plus negative 2 pi. So pi over 3 minus 2 pi would be negative 5 pi over 3. I believe, hold on, let me think about that for a minute. Yeah, it should be negative 5 pi over 3. Now here's if you plug negative 1 into the second equation. You'd have 5 pi over 3 minus 2 pi, which would be negative pi over 3. Likewise, you'd have two obvious solutions, pi over 3 and 5 pi over 3. And if you were to plug positive 1 in for k, you'd have pi over 3 plus 2 pi, which would be 7 pi over 3. And then plug positive 1 into the second equation. That would be 11 pi over 3. If you were to plug positive 2 in for k, that'd be pi over 3 plus 4 pi, which would be 13 pi over 3. And then plug positive 2 in for the second equation, that'd be 5 pi over 3 plus 4 pi. That'd be 17 pi over 3. If you notice right here, we have our 8 solutions, so we can quit. There are infinitely many solutions to this. Now for this example, it says solve the equation 2 sine of theta plus square root of 3 is equal to 0. And we want all angles from 0 to 2 pi. So let's solve for sine of theta first. So if we subtract square root of 3, we have 2 sine of theta is equal to negative square root of 3. Now to solve for sine, you have to divide by 2. So we have that the sine of theta, the sine of our angle is equal to negative square root of 3 over 2. And we want all the angles from 0 to 2 pi, where the sine is negative square root of 3 over 2. So now, remember, sine is negative, and it's negative in the third and fourth quadrants. So the angle where sine is negative square root of 3 over 2, it should be this angle here should be at 4 pi over 3 and 5 pi over 3. If you prefer degrees, it would have a reference angle of 60 degrees from the horizontal. So the angle that is 60 degrees past the x-axis in quadrant 3 would be 240 degrees, or 4 pi over 3. Likewise, the angle that's 60 degrees below the x-axis in quadrant 4 would be 300 degrees, or 5 pi over 3. So our solution set would just be the angles 4 pi over 3 and 5 pi over 3. Okay, so for this example, you have the equation sine of 2 theta is equal to 1/2. And we want all the angles from 0 to 2 pi. Now, sine is positive in the first and second quadrant. And the angle that gives you a sine value of 1/2 is 30 degrees from the horizontal, or 30 degrees above the horizontal, so in the first quadrant that angle would be 30 degrees or pi over 6. And in the second quadrant that angle would actually be 30 degrees above the x-axis, so that'd actually be 150 degrees or 5 pi over 6. Because this 30 degree, how we talk about being 30 degrees above the x-axis, that's what we call a reference angle, in case I failed to mention that. Yes, the reference angle would be 30 degrees, and the angle that gives you a sine of 1/2 would be pi over 6 and 5 pi over 6. But since sine is periodic with a period of 2 pi, That means if you multiplied, or if you added any multiple of 2 pi, with k being any integer, you would still get a sign of 1/2. So if you added this multiple of 2 pi to pi over 6, you would get 1/2 after you plugged it in. If you added this multiple of 2 pi to 5 pi over 6. But keep in mind, whenever we're solving these, we need to set them equal to whatever's on the inside, which would be 2 theta. So now, let's solve for, we want the angle, the particular angle, so let's go ahead and divide everything by 2. So this 2 theta divided by 2 is just theta. 1/2 of pi over 6 would just be pi over 12. Then 2k pi over 2 would be k pi. And then for this equation on the right, divide everything by 2. So we have theta is equal to 5 pi over 12 plus k pi. So now, we need all the angles from 0 to 2 pi that we can generate from both of these equations. So, if you were to plug in -1 for k, so if you were to plug in -1 for k, then for this first equation you'd have theta is equal to pi over 12 plus -1 times pi, which would be, that'd actually be pi over 12, so pi over 12 minus pi. Remember, you can rewrite pi as 12 pi over 12, so that'd be -11 pi over 12. So we know at least with this first equation here, we have to start with k equals 2. Likewise, if we were to plug in -1 to this second equation, you have 5 pi over 12 minus pi, so that'd be 5 pi over 12, then minus 12 pi over 12. So that'd be -7 pi over 12. So again, we have to start with k equals 2 in order to find the solutions. I don't know why I said k equals 2. It should start with 0 because we showed that -1 generates angles that are not in our interval, so we have to start with k equals 0 for this instance. Since there are no negative angles that are in our interval, we have to start with k equals 0. So now let's start with k equals 0. Now, if you plug in 0 for k, you get, for the first equation, pi over 12 plus 0 times pi, which is just pi over 12. And for the second equation, you have 5 pi over 12 plus 0 pi, which is just 5 pi over 12. So you get the same equations we started with. If you plug in k equals 1, you get theta is equal to pi over 12 plus 1 times pi. But remember, 1 times pi is just pi. Pi can be rewritten in the same denominator, 12 pi over 12. So pi over 12 plus 12 pi over 12 gives you 13 pi over 12. Likewise, if you do the other equation, you have theta is equal to 5 pi over 12 plus 1 times pi, or just pi, Remember pi, like in the last equation, pi can be rewritten as 12 pi over 12, so 5 pi over 12 plus 12 pi over 12 gives you 17 pi over 12. And since we want to limit it to 0 to 2 pi, you keep going with values of k for both equations till you get angles that are more than 2 pi. So remember, 2 pi, since the denominator is 12, you'd keep going until you got angles that were more than 24 pi over 12. Alright, so if you keep going in that manner and keep plugging in values of k, this is what you should get. Notice if you keep going, when you plug in k equals 2, you get 25 pi over 12 for the first equation, which is more than 24 pi over 12. Likewise, 29 pi over 12, greater than 24 pi over 12. So these six answers, or these four answers rather, pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Those all work those all fit your equation. Here's another example. Solve this equation. Tangent of theta minus pi over 2 is equal to 1, with our angle being from 0 to 2 pi. So remember, the period for tangent is just pi. And remember, tangent is equal to 1 at pi over 4 and at, I believe, 3 pi over 4. Because in the first quadrant, both the cosine and sine, they're both positive, and in the third quadrant, which means that should be 5 pi over 4, not 3 pi. In the third quadrant, remember, they're both negative. So, our angles we would get by adding intervals of k pi to both angles. But wait, they're not equal to theta. They're actually equal to theta minus pi over 2. So if we want to rewrite these, we would have theta minus pi over 2 is equal to pi over 4 plus k pi. And also, theta minus pi over 2 is equal to 5 pi over 4 plus k pi. So if you add pi over 2 to both sides, we want to solve it for theta. So theta is equal to pi over 4 plus pi over 2 is 5 pi over 4 plus k pi, because you have to add these together. So whenever we add pi over 2 to both sides on the second equation, we get that theta is equal to 5 pi over 4 plus pi over 2, which I believe would be 7 pi over 4, plus k pi. Wait, this pi over 4 plus pi over 2, let me make sure that's right. Pi over 4 plus pi over 2. That can be rewritten as 2 pi over 4. So that should probably be 3 pi over 4. So we know, so if we plug in 0 into k, we know that 3 pi over 4 and 7 pi over 4 are both solutions. However, we need to check to see if there are any other angles that are in our interval from 0 to 2 pi that we can generate with these equations. So if we plug in negative 1 for this first equation, that'd be 3 pi over 4 minus pi. So that would be the same as minus 4 pi over 4, which would be negative pi over 4, which is not in our interval. And if we were to plug in negative pi over here, that'd be 7 pi over 4 minus pi, which would be 4 pi over 4, which is 3 pi over 4, which we already have listed. So now let's check k equals 2. Or k equals 1, actually. I do know. Yeah, let's check k equals 1, because we checked negative 1 last time. So, let's check positive 1 for k now. So we'd have 3 pi over 4 plus k pi, or plus 1 pi, or just pi. Remember, that's the same as adding 4 pi over 4, which is 7 pi over 4, which we already have. And if we plug in 1 for k into the second equation, we have 7 pi over 4 plus pi. Remember, that's the same as 4 pi over 4, which is 7 pi plus 4 pi is 11 pi over 4. 11 pi over 4 is not in our interval, so these are our only two answers. Now, let's solve this equation 2 sine squared, or it's 2 sine squared of theta minus 3 sine of theta plus 1 is equal to 0. So if we let's do a little bit of substitution, let a equal sine of theta. From there you'd have, instead of sine squared, you'd have a squared minus 3a plus 1 gives you 0. Now if you want to factor this down, you could factor down 2a minus 1 times a minus 1 equals 0. I assume you all know how to factor by now, but if not, you can ask me during class how I got this. But anyway, from here you get that a is equal to positive 1/2, and a is equal to 1. Now remember, a is equal to sine of theta, so we need where sine of theta is equal to 1/2 on this interval, and where sine of theta is equal to 1. Now if here there are two angles in our interval on the unit circle that give you a sine of 1/2. That would be at pi over 6 and 5 pi over 6. And then where sine is 1 on our interval, that'd be at pi over 2. Alright, so here's another example. Solve this equation. 3 cosine of theta plus 3 is equal to 2 sine squared of theta. Now we have a sine squared, but we have cosine, so we need to get one of them to look like the other. It might be easier to get the sine squared to look like cosine squared. Because remember the trig identity we have, sine squared plus cosine squared is equal to 1. If we subtract cosine squared from both sides, you have sine squared is equal to 1 minus the cosine squared. So now we can substitute that in, and that would look like 3 cosine of theta plus 3 is equal to 2. Instead of sine squared, it'd be 1 minus cosine squared. Because what we're doing is trying to create a quadratic equation with trig functions like what we had on the previous slide. So if you distribute, that'd be 3 cosine of theta plus 3 equals 2 minus 2 cosine squared of theta. So now if you subtract 2 from both sides and add 2 cosine squared, so now if we get everything on the same side, you have on the left-hand side 2 cosine squared of theta plus 3 cosine of theta, then 3 minus 2 is 1, so plus 1 equals 0. So now, if we let a be equal to cosine of theta, we have 2a squared plus 3a plus 1 gives you 0. We can figure out that that factors down to 2a plus 1 times a plus 1 gives you 0, which means that a is equal to negative 1/2 and a is equal to negative 1. So now we know that cosine of theta is equal to negative 1/2, or cosine of theta is equal to negative 1. Now we know cosine is negative on the left-hand side of the graph. So for cosine of theta is equal to negative 1/2, we have theta is equal to 2 pi over 3, and also 4 pi over 3. Those are the angles on the left-hand side of the graph where the cosine is negative 1/2. And when cosine is negative 1, at pi. So our solution set would be 2 pi over 3, pi, and 4 pi over 3.